So we got quadratic functions. This is going to take a couple days to get through. We've already solved quadratic functions. That's when we did the completing the square, factoring, quadratic formula back about a month ago. Now I want to focus today on graphing quadratic functions. So whenever I graph a quadratic function, it's that squaring function that we talked about in the last unit. You're going to hear me refer to it as a parabola today. The most important part, I think, of the parabola is the vertex. And the vertex is just going to be the extreme point. It's going to be the maximum or minimum value, which we're going to get into with the next video tomorrow. It does have an axis of symmetry. This squaring function, this parabola, will fold over onto itself. And so I'm going to illustrate all of these definitions, except for maybe the max and min on this next slide right here. So I'm just going to draw just a random parabola somewhere. I'll just pick down here. Have it come up. I'm trying to make it so it's level. That one's not good at all. I want to restart. So let's just go ahead and try that again. Maybe red will work better. I don't know why I chose red then. That's close enough. Close enough will be good enough. So, like I said, the most important part of this is its lowest point down here. Or this parabola might be opening down, so it would be the highest point. So it's either the lowest or highest point on the parabola, known as the vertex. One point that I'm interested in is right here and right here. That is known as the x-intercepts. Okay, we've already worked with x-intercepts. Whether you know it or not, x-intercepts were all those solutions. Solutions that we found back in the first unit. We also call them zeros. We also call them roots. When we factored the x minus this solution, that's what we're talking about when we touch on those. We're going to come back to those maybe in a couple weeks when these quadratics get longer and turn into polynomials. Now, so those are x-intercepts. It actually shares the same point that it is a y-intercept with. So this point would be the y-intercept. I'm going to be using it today, along with this imaginary line that runs down the middle. Okay, and so this is known as the axis of symmetry. The idea with the axis of symmetry is that if I was to fold this parabola over this axis of symmetry, it should fold over onto itself if I've graphed it correctly. Okay. Now, common mistake, a lot of people want to put the axis of symmetry right here. They always want it to run through that y-intercept, but it doesn't. The axis of symmetry will run through the vertex every time on these parabolas. Okay. So first thing we want to do is talk about the different forms that you're going to see of a quadratic function. Okay. The one that we're going to be using more of is this ax squared plus bx plus c. You're going to hear me refer to that today as general form. Okay, general form. The other type of form that we have is called standard form. It's also, I might accidentally call it vertex form. That is another name for it. Standard form or vertex form. And that's whenever I have it written like this. F of x equals a times x minus h squared plus k. That's exactly what we did in the last section when we did transformations. Okay? But more specifically now, I'm going to be able to pull out this hk, and that is going to be my vertex. So we will come back to that in just a little bit. These equations at the bottom I will come back to as well in just a minute whenever we're ready for them. So I've spelled everything out as to these next steps that I'm about to do on the next slide. I'm going to kind of go through each step very slowly so you can see each one. But if you want to pause the video and read this, you're more than welcome to, or you can come back to it when you're working on your homework. So they're going to give me a graph, and it is my job to write an equation for this in standard form. I'm sorry, in general form. What's general form? So I'm going to start off with my f of x equals x squared. I'm going to write this so it looks halfway familiar to you. Remember whenever we had to expand everything out? Yeah, it's exactly what I'm going to do here. So I'm wanting to use my transformations to get to my general form. That's exactly what we did in the last unit. So this parabola is not sitting right here at the origin where it normally is. It's been moved to the left 2 units. Remember, everything left and right goes on the inside. It's opposite. So you would think put -2 in parentheses, but in fact I need a +2 in parentheses. And then this parabola has been moved down 3 units. Okay, up and down goes outside the function, and that's a big chunk of it so far. One thing that is hard to determine on this is if this parabola has been compressed or stretched. And we're just going to worry about that in the positive, or in the up and down direction, in the vertical direction. So I'm just going to put an A out there to help me out with this. Now, next up, what I want to do is I want to find another point that's not the vertex that's on my graph. The nicest point I can find, I love using 0. So I'm going to choose this point right here, 0, -1. An extra point that's not the vertex on my graph will help me find what the stretch factor or the compression factor is of my parabola. So I'm going to take that 0, -1, and I'm going to plug 0 in for this x, and I'm going to plug -1 in for the y. And I'm just going to solve the rest of this, bring it all down, and solve the rest of this for a. So I get 0 plus 2 squared is 4. I'm undoing what's being done to the a, so I need to add 3 to both sides. And so I get 2 equals 4 times a. Divide both sides by 4, and I'm going to get a to be 1/2. So this parabola has been condensed by a factor of 1/2. So now I can come back up here to my original equation, and I can plug a 1/2 in for my a right there. And everything else comes over. Now, if it just wants this in standard form, I'm done. All right? This is my standard form, or my vertex form. But it wants it in general form. It doesn't want any parentheses. It wants it in that nice ax squared plus bx plus c form. So what I'm going to have to do on this is I'm going to have to simplify it. I need to expand this binomial. So I'm going to square the x, multiply the 2 and the x together, double it, and then square the 2. Distribute the 1/2. I'm just distributing it through the parentheses, so the -3 doesn't get 1/2 distributed to it. And as my old professor used to say, lo and behold, we have arrived at the general form. Nothing too hard there, but we need to practice these tedious steps to get to there. Let's try this again. That one was kind of weird. Again, I'm going to start with this vertex form, okay? My standard form. I don't know what a is. And if I just put in my translations, it helps me. Well, let me show you a shortcut of why this is called vertex form. It's because my vertex is right here at -2, +4. So if I plug in -2 and +4 into this, remember the -2 goes on the inside, so I'm going to do the opposite to +4. So I should always be able to look at this and grab my vertex if I need to. So that's a little bit of a shortcut. We don't have to do translations as much. All right, do you see a nice point on here? There's several nice points on here, but man, I really like that one right there, 0, 0. So let's plug in 0 in for x and 0 in for y. And then we'll solve this down for a. So we get 0 equals a. 4 plus 4. Subtract 4. We get a equals -4 equals 4a. So a has to be -1. A equals -1. Does that make sense? Yeah, it means it's been reflected, right? This graph has definitely been reflected because it's facing down instead of up, not in that standard position. So good. All right, go ahead and pause the video, expand that out. If you get stuck on the expansion, it's the same as the last expansion. So you can go back and look at it. So I got negative x squared minus 4x. I like going the other way better. I like graphing these. It's kind of tedious finding that a and getting everything plugged back in, expanded out. And working with this, we're going to be generally working with general form. Okay, we're not going to be doing a lot in that standard form because we already did that in the last unit. So I want to work with this just in the general form. What I want to do is I first want to identify my a, b, and c. I'm going to be given stuff that's going to hopefully be in this form, ax squared plus bx plus c. And my first thing I'm going to do is I want to find the h. Okay, my vertex is going to be in the form hk. So h is going to be the x coordinate of my vertex. And to get it, I have this nice little neat formula right here. I remember it because it's part of my quadratic formula that I had whenever I was solving these. The x equals negative b plus or minus square root and so forth. Except for I don't have the plus or minus square root part. I just have the x equals negative b all over 2a part. Please excuse my singing, that was rough. To find the k, I'm just going to be plugging whatever I find for my h back into the function. Let's try it with some numbers, see if I can make more sense of that. Okay. So I'm given this function, and so I want to first of all find the vertex. I want to find the most important point, and then hopefully I will be able to graph this. So my first point, my vertex, is going to be hk. So to find out what the h is, I want to keep the parentheses there. My little formula is negative b over 2a. So I'm coming over here. I'm going to label my a, my b, and my c. My b is negative 8. So if I have a negative 8, that's going to give me a positive 8. And then 2 times a. A is negative 2. So 8 over negative 4 is negative 2. So my k coordinate is negative 2. To get my k coordinate, the second coordinate, or the y coordinate of my vertex, what I'm going to do is I'm going to take this negative 2 and I'm going to plug it back into this function. So essentially, I'm just finding g of negative 2, g of whatever I just found on my h. So I plug that negative 2 back in. Plug it in for all those x's. And so this gives me, let's see, that gives me a positive 4. So negative 8 plus 16 plus 3. I do believe that's 11. So I have my vertex. Big sigh of relief right there. I've done a majority of the work. I haven't even started graphing it yet. Remember that vertex is my most important point. So I'm going to go ahead and plot the point negative 2, positive 11 right here. I'm going to let you know a little secret here. Something you probably already knew, but I'm going to bring it to your attention. See that plus 3 hanging out on the end of the equation? Just like on y equals mx plus b, this is ax squared plus bx plus c. This is going to be my y-intercept every time. Whatever number is floating on the end tells me where this thing's going through my y-axis. So I put a dot there. The last thing I want to do is I want to use my axis of symmetry. Remember I told you my axis of symmetry runs through the vertex. So it runs through that most important point. And so remember, this parabola has to fold over onto itself. So I'm just going to count. If I go 1, 2 units over to get to this blue dot, that means I need to go 2 units the other way, and I can have another dot. Connect these dots with the U, left to right, you have your graph. Watch all this again if you need to. I want to turn you loose on this one and see how far you can get on it before I put up the homework slide. Go ahead and try it. There's a couple tricks at the beginning, so you might have to do some erasing whenever you see it. All right, this is what I got. A little trick up front. My equation was not in standard form. I had to rearrange it and then get my A, B, and C. Other than that, it all came out nice and sweet.